Today I'm going to try and take you through a journey of an industry that is on the verge of a major inflection point. As you heard Sanjeeva say before, we are going to be all about connected device, connected car, connected business. And somebody has to connect all those things together. And if you think about today, you have one cell phone. Tomorrow you're going to have maybe 100 devices in your house and in your car and on your person. And so all of this is causing a major inflection point in an industry where I can guarantee you in 5 years from now, your service provider, your mobile service provider, and your internet service provider will not be the same company. It might not even be the same company. So inflection points and technology changes creates opportunity, and there'll be a lot of change. So it's a very exciting time. I compare this to the times in the late 90s when the internet started coming out. Today, it's a similar time. So I will talk a little bit about the network function virtualization, which is the hot topic in most of the industry these days. What we are going to do with that in the telecom cloud, and how we're going to use the cloud. And then I'll show you a little bit about what we did with the Stratos, the WSO2 Stratos that became Apache Stratos project, and the virtualization and orchestration system that we're building. So here's an interesting graph. It is today, it represents the cost models of the service providers, mobile service providers, where we have a very fixed average revenue per user, but we have a present mode of operation, which is a classical deploy hardware, administer individual hardware components, and an organization that is actually going up. And the reason it is because you were on 2G and you had little bandwidth, and then you were on 3G, and then you went on to LTE, and your bandwidth in your phone has increased exponentially. Also, the amount of devices is increasing. You're starting to have more than one device. I might have one phone, but I have a phone and a car and something else, right? So now all of this is causing a major increase in the devices and cost of operating this network. However, you're not really paying any more. In fact, you're probably paying less today for your mobile phone bill than you used to. So that's causing a major problem. And this is one problem that we are trying to solve by using the cloud model and try to virtualize all the things that used to be pieces of hardware, very expensive and very time-consuming to deploy, and deploy those in the cloud. So we get to what we created a term called telco cloud, which is the telecommunication cloud. It is what is the equipment put in there? What can we virtualize? So we can virtualize, routers and switches and so forth. And there's open source models, and there are models of the things that Cisco sells. But however, one thing important to understand is that really there's a basic rule. Things that just move packets, that don't do much, will not virtualize well. I don't believe there's ever going to be a virtualized version that's efficient of the CRS-10, which is the biggest router Cisco makes, for example. That just isn't going to work, because this purpose-built hardware for just moving a packet is always going to be more efficient in cost and power than anything virtualized. However, that's pretty much maybe a few percentage of the whole infrastructure of a service provider. Most of it are things that actually touch the packet a lot, look inside the packet. One of the things that you might think you have some privacy in your cell phone, but you don't. Every service provider inspects every packet. So when you fetch a web page, you might have 10 different flows. The service provider will look at each one of those flows and apply individual policy to it and account for it and count the packets on each one. So they do a lot of things per packet. And that causes a big cost. And then today, mode of operation, what we have is these huge things called packet core. Cisco makes one of the most popular. We have most of the market in that area. They are very expensive purpose-built hardware, which needs to, this is designed to handle a certain amount of devices, which is built for the amount of cell phones you have today. Once you start going into a connected world, this is going the cost is going to skyrocket. So we need to do something to make it easier to manage and administer. So what is the telco cloud? Well, the telco cloud is a set of components that your service provider uses to provide a service. So it could be a voice over LTE network. It could be a policy engine. In general, in a mobile service provider, there is always every single operation is checked against the policy. There's a centralized policy engine where you put all your policies as well. This person is on this specific plan, and he can do this, and this is his maximum data allowance, and so forth. So that's where it is. It could be, an ESB. We built a system based on the WSO2 ESB to create certain use cases with a web interface from mobile service providers, API gateway, and so forth. This telco cloud need to be a new model. It needs to be elastic. It needs to be easy to operate. It needs to scale to a different level so that we don't have to look at all these individual devices and try and manage this network like we used to in the past. And it's, what do we call this? Well, maybe it's a platform as a service. Maybe it's more a software as a service. There are some components which are common, like we could say it's a telco platform as a service, but yeah, I would call it more a software as a service at the end of the day. Now, this is just to give you an idea. This particular diagram is for the voice over LTE network. When you switch to LTE mode, there's no more classical voice channel like it used to be in the 3G and 2G environment. Everything is done over IP. So it's like Skype on the internet. It's a similar model. Now, each one of these components does a different function. The TaaS is your voicemail, for example, telephony application server, and so forth. I won't go into much details and bore you with all of this, but the idea is that this is just one component. Each one of these boxes is 3 to 6 virtual machines when you virtualize it. So at the end of the day, you're going to have about 24 virtual machines, and that's like in the minimal configuration. So when you auto scale this, the 24 could become 200. Right, and so you can imagine the amount of complexity, the amount of sheer number of virtual machines here is fairly significant. So we have to do something a little better. We can't just bring up these things and start monitoring with the network management system like we used to do. That is not a model that will scale in cost, in operational cost. So how do we handle this? Well, so we need to handle the complexity. We can virtualize different things, NATs and forwarders and so forth, policy engines. But how do we make this easy to operate? In order to make it easy to operate, we need to try and put them in a box like it used to be. A long time ago when I actually did some things with IBM controllers. You had a controller and it could have 2 modes. It was either up or down. It was pretty simple. It didn't have I'm missing a route, I cannot click there, this program doesn't start. It had up or down. And so that was a much simpler model. Now, the reason why, if you automate everything behind it, maybe we can get to something that's similar or close to that model they used to have and simplify the life. So the complexity is an interesting problem because when you automate the infrastructure, you add some complexity. So we need to do something a little better than just adding complexity. As I said, we need to make it simpler to the operation. And how do we do this? Well, we cannot really mask the complexity by adding a traditional network management system where you still have individual elements, you just have a system that manages the individual elements. We need to have a different set of controls. We need to give up some controls, like in the IBM case where we deliver up or down. We didn't really know what was happening at SNA protocol level and why it was down, but it was good enough. I had to do certain things and I get it back running. This is a very good reason. We need to give up some control of this network. We need to put some abstraction layers in, and we need to kind of stick to that particular control. So micromanagement of networks, like today, everybody networks are highly micromanaged. You really go down and you understand every router, and every device is individually addressed and so forth. And so we need to, in a virtualization environment, when we start blowing up these devices to devices that are in the hundreds, and they appear and disappear depending on what the load is, it is much more difficult, and it's not possible to manage in the same way we used to before. So similar interesting paradigm in this example, in the airline industry, you have a baggage system that is very, very controlled. It knows exactly where to put the bag and where to go. And yet you have an air traffic controller who is in charge of controlling the system, but it just says, go here. And then the pilot is the one who actually knows how to go in that particular direction. And the pilot has all the complexity. So to the air traffic controller, it's very simple. Go there and the pilot executes. And so in a similar way, we need to come to a similar environment where I say, I want a VoLTE, a voice over LTE system. Please, create one. And it creates one. And today, if I go do that, basically I have to issue a PO, and then I have to wait 6 months, and the whole team comes along and starts installing lots of boxes, and then eventually 6 months later the system is up. What I want to do is I want to push a button. I want to have a long coffee, maybe 40 minutes, but when I come back, it's all done. And we have achieved some of this technology already. So how do we achieve this simplicity of operational while handling some very large systems? We create some layers. So layers provide different interfaces to different systems below it. So, for example, the infrastructure as a service, you can have many ones. You can have VMware, vCloud, and so forth. We can have OpenStack. You provide a fault isolation. When something happens in the layer below, you might not even notice, or you might just have to request the same operation again, and it just happens again. So you don't have to know what went wrong and how it got fixed. So there's a lot of different advantages. Administrative boundaries. So you could have an organization handle one layer and an organization handle a different layer. So it's a very valuable. Abstraction layers are very valuable, but as I always stress to my team is you should never violate them. They always end up with something, okay, well, we didn't have an interface with JClouds to do this, and so we kind of went around and did a call through to the infrastructure service, or OpenStack in that case, and then said, yes, okay, but when I change that will break, right? And so it's very important that the value of an abstraction layer is abstraction. If you go and try and go around it because something is not fitting the service, then it doesn't really work well, and then you kind of nullify the value add there. So at the same time, because we are trying to hide the complexity and create as macro systems which are easier and simpler to operate, we're going to use virtualization layers, and we're going to hide some of the complexity. So we're going to simplify some of the procedure. For the capacity planning, for example, is no longer a complex function that needs to handle the kind of network and the kind of links and so forth. It might be just as easy as saying, I'm going to deploy more servers. And because I'm running out of infrastructure at that point, and that infrastructure doesn't really have to know what those servers are used for. They could be used for a web service. They could be used for the voice over LTE. As long as I have a service level agreement that I will be running in a certain way, it doesn't matter. So now I can hire a different organization to manage those servers. This is going to lead to a change in organization. So businesses will have to change the way they're doing. Otherwise, what you end up is with multiple clouds, because one department has its own completely vertically integrated with a cloud, one private cloud and another private cloud. So you now start spending more money and having more complexity. So and this is going to be a tough one for service provider, because it's some of the companies have been around for 100 years, are organized in a specific manner, and they're going to have a tough time adapting. But they must in order to survive. This is the world of high technology business. And then we get to the last topic, orchestration. Orchestration is an interesting word. It's very catchy. and marketing people love it. So we orchestrate anything in the networking world these days. But I think the only second term catching to that is Sanjeeva's complex event processor. Everybody loves complex event processors, and it's a cool technology, but it's very hyped by marketing. So I wanted to kind of show you a little bit simplified version. This is something that's easier to understand. Well, I'll show you next is the official standards from the ETSI standard body. So in here we have a top level of orchestration where we say this is where we orchestrate the service. Basically, I say I want one of those, one of those, one of those. Please just connect them together, but I want maybe a policy engine, I want a voice LTE engine, I want an ESB here, and I want a web server there. And that's what the top layer does. The next layer down is what handles and to a certain extent creates the simpler blocks. That is where Apache Stratos is, for example, where it takes a policy engine and creates all the databases below and all the things that needed to create the full policy engine. So, and it also makes it auto scale so that I don't have to worry what kind of capacity and so forth I need there. And then below that, we of course we have a layer of JClouds, which is to interface to the problem, because today we have not consolidated the infrastructure as a service yet, and so we need to handle many of them, and so that's where we have an adaptation layer for that. And of course, we have a hardware below that. Now, having said that, let's go to the official one, which is this is the standard drawing, and I don't want to go through all the different details and put you all to sleep with this, but the layer from the bottom, the virtual infrastructure manager, is what we equivalent to OpenStack and vCloud and so forth, while the middle is the virtual network function manager, which is what we equivalent to Apache Stratos and a few more things around it. And then the top is an abstraction layer, which is the orchestrator, what I call pretty much a true orchestrator, which is what creates the services and put them together. Now, this is where the standard bodies have kind of gone in this direction and created a few more links, but at the end of the day, I think there'll be an evolution even in this architecture, and we'll have to see how the complexity stands up with time. So we have today lots of infrastructure as a service providers. Of course, there's been a few of them are fading, but everybody seems to want their own APIs and their own different ones. vCloud, OpenStack, Nimbus is actually a new Cisco initiative that is using basically OpenStack to create a public cloud. So there's all the different ones. And so we need to handle that. I don't want to be in a argument or a war about this IIS is better than the other one and so forth, right? So we need to handle that. That's one of the first requirements. And the other problem is that software is just not perfect. We all know that. But there's when you start trying to take an application and virtualize it, it is a fairly complex business. Applications don't start. They have dependencies. You might have a database that has to start first, or you have a bug currently in Cassandra they haven't solved where you have to have a arbiter start first, and then you have to have the other pieces start later. So you have a lot of dependency, and then if a failure happens in a database, for example, the clients of that, the user of that particular service might hang. And then you have to restart the whole system. So there's a lot of complexity and dependencies in this business. And so when we started trying to go and virtualize applications, some of them were friendly, some were not. We took one of our competition's virtual firewalls, for example, and virtualized and orchestrated that. So there was no cooperation at all there. We cannot really change the applications. The bottom line is we would like to. I mean, one of my teams said, yes, we have all these problems and we need to fix the problems, but realistically we can't do that right now. And so we need to handle that, which means that the orchestration system or Apache Stratos at this time, it needs to be able to handle all these dependencies and rules that we need to put below it. The other problem is that when you monitor an application, if it's not a web server, what happens is you really need to monitor what the service is. For example, in a voice over LTE, I should really try and place a call and see if that works, right? That would be a logical thing to do. So that's pretty much what we do. We just try to register and see if what the delay is, and that gives us what the amount of liveliness and what the load is on that particular system. So it's not easy. It's not the same as trying to just make sure that something is alive by pinging or getting a web services, make sure the web pages can be fetched. So that's not enough. Each application have its own specific requirements, its own dependencies and auto-scaling. And so we need to build that in the system as well. We need to be able to handle that. And then one of the last things is of course, the availability. All of these systems have to be extremely highly available. And the classical model of having a primary and a secondary system, if one fails, ever takes over, doesn't really apply this here, because we can, in a virtual environment, we can have, maybe we can create a service again, maybe we can just switch to a different availability zone in infrastructure as a service. OpenStack has a concept of availability zones. So we really need to have to handle this availability. We also, the other thing we need to do is handle erratic behavior. You could have a situation where there's a sudden emergency and everybody reaches for a cell phone and everybody calls everybody. That's a huge spike in traffic that somehow needs to be handled. As you know, we've seen in some instances, like in the few years ago when there was an incident in London with the bombings of the metro station, the phone networks were completely congested. Nobody could place a cell phone call at the time. And most of that, it was due to the fact that it's still circuit switch technology. You had X amount of channels, and once you're out of channels, that was it. The only thing they did is if you call 999, the emergency number, they would knock somebody off the phone, and they would, connect that call. It was just a very basic priority. But in an environment where we can virtualize this, maybe we can do something different, in the sense that we can start creating more infrastructure as the demand happens, and actually can handle a much larger volume of calls, so we don't end up with a sad situation. Voice calls, for example, consume very little bandwidth. If you think about a call that consumes about 8 kilobits of bandwidth in a link that's sustained on LTE, maybe 50 megabits, you can make a hell of a lot more calls than you used to be able to do that on a regular circuit-based solution. So we have to handle these in a different way. So there's a lot of new requirements on availability and new models which will reduce the cost and enable us to handle a lot more device in volume and in capacity. So next, I want to show you a little bit what we need to do to orchestrate a service. So the first thing we do is we have a configuration template for the infrastructure as a service. We need to, if we go into a private cloud situation where we need to create the cloud, somebody has to actually create that. And so we create that cloud, and then we give the credential to the system that we want to deploy. Then we have to describe all the entities. We have to say, okay, we want the policy engine. We want a particular set of virtual machines that create a virtual voice over LTE network, for example. And then at the end we have to orchestrate all of this. We have to make sure it comes up and runs smoothly. What I'm trying to achieve is what I explained before. I want to push the button, go for a very long coffee, and then come back, and I have a full operational system. This is what is going to be necessary in order to handle the sheer amount of device and volume and keep the cost to a reasonable level. So what does, when we were looking to build this system, we looked around quite a bit. We looked at all sorts of different open source projects and different companies and so forth. And it turns out that there was really nothing that was even close to try and meet the requirements that I explained before. And so we started working with WSO2 on the Stratos project, which, when it started out, it was a monolithic system. And as Sanjeeva said, we keep reinventing all of this technology. And it went quite a ways from there to the Stratos 4.0, where it's, a modular system where we can swap in things in and out. It's now a message bus-based system, so we can have different components, announce what they're doing, and we can swap different components in and out, and all of this is led to something that can handle a lot more than just a web services engine. It's built out of open source components. That was very important because we want to make sure that if we have a problem of scalability in one of the systems, and we can swap it out and put something better there, and it's not a complete rewrite of the system. So that was kind of one of the design parameters for this. This was quite to be a new original technology we had to put in there. There's a lot more requirements when you're trying to virtualize and orchestrate a random application or a network-based application than it is when you do a web service. So if you look today, there's several systems out there that do web services. They just basically handle Elastic Web Service and things like that, but that's a much easier problem. One of the things I have to do, for example, I have to support multiple networks, and we ran into issues where we had to go and interface to a different JCloud's API in order to be able to provision like 5 different networks instead of 1. We had to create the concept of group. There are applications when I have a system that uses, let's take a web service example, a web server with a database behind it, and a database has 3 components. I might want to create a group with all of those things together so that I have a dependency when they start in a proper order. I start the database before the web server. I could also have a situation where I want to basically auto-scale it in a certain way. After I auto-scale X amount of web servers, I might want to start scaling up the database to handle that traffic as well. So there's a lot of different dependencies and things that we built into it. So we created a concept of groups and dependencies. I made that recursive so we can create a group and then have a group be part of a different group. We also had to streamline the configuration so we can kind of handle it independent of the cartridge subscription. So there's a lot of different technologies and things that we worked on to expand Apache Stratos to what it is today. So what's next? We're going to put more technology in it. I think we want to go from the virtual machine-based model, which has been, everybody has kind of been using that because it's easy to do. It creates a very large installation layer, but it's not efficient. It takes a couple of minutes to start a new virtual machine. So you really want to do something a little better. If I have a well-behaved service, maybe it's a Linux process, right? Why do I need to start a whole Linux operating system to just run one process? I mean, it's not logical. So we want to try and do this at a process level. That's where we're exploring Docker Linux container model instead. We want to have other models. For example, one of the requests that I've got that was kind of surprised that for operational reasons that people are a little bit afraid of the change. So they don't want to have everything automated. They want to have a manual auto-scaling. They want to say, okay, I want 5 of those. And then tomorrow I'll wake up and I'll want 6 of those, right? And so we need to put some of those models back because we went right away with the fact, okay, you don't want to deal with any of that. We want to just have everything completely handled automatically, but that doesn't seem to, some people are kind of afraid of that, and so we need to go do that. And then, of course, the last thing I think I'm looking more at a longer term, we need to have some network aware concepts inside inside the orchestrator in such a way that I can say, This particular application needs guaranteed the service level agreement to reach some of its users a little bit, so I can pass some of that information through the OpenStack layer. And this is going to require quite a bit of work with OpenStack and different infrastructure services, because you're going through kind of three layers there that we need to handle. So there's some of the things that we're looking at doing in the future. But at the end of the day, what we're trying to do here is really transform an industry from a hardware-based traditional model to something that can handle 2 orders of magnitude more devices than is there today. We want to have this done in a way where the complexity does not scale exponentially with solving the problem, so that we can end up in a model like they used to be, a much simpler operational model, so that we can maintain the operational cost to a certain extent. And we're looking at evolving the orchestration system. I think we're just starting. We're kind of leading in the problem solution space right now, but we're just starting, and I'm kind of confident that in the next few years things will look very different, and most likely it's going to be hard to even imagine what it is right now. So any questions? So I'll be around for the next couple of days. So if you find me in the corridors, you can stop and ask some questions, and I'll be happy to answer.
I have a question.
Oh, Paul.
So this is a very, as you say, it's a huge inflection point.
Yes.
How do you see, in 5 years' time, what's going to be different, both to the telco and to the user? What's going to be the outcome of this that's going to be different?
Oh, my crystal ball is cracked, so it's hard to say. I can tell you, there's going to be, your mobile phone provider will probably not be the one it is today. You might see some companies that's been around for a very long time disappeared, the same way we saw in our business in the late 90s. I mean, you might also see other technologies. I think there's going to be some emerging technologies that will cause the connectivity of devices to be a little bit different. One of the problems today, for example, in cell phones, we're trying to solve an issue that with high bandwidth, a limited amount of devices. When you go into a connected Internet of Things, the problem to solve is very different. It's very low bandwidth, but millions of devices. So it's a completely different problem. So I think the technology that is here today to do cell phones will take us to a certain point, but then there will be a different technology, and we see some things happening which will compromise bandwidth for reach and the scalability. Because at the end of the day, you also have to have low power, right? If you're going to have a jacket that's connected and it does something, right? You don't want to have a bulky battery running. So there's going to be a little bit different problem. So cell phone technology or mobile network technology is only going to carry us so far. Sorry, I couldn't quite.
The NFV platform that you're building, is it going to be hosted in Cisco, or it's going to be hosted in the telco data center?
It is both, both models. So it is built to be, today the first interaction is all private cloud. So what's what the service provider want? They want control, and so they'll create a private cloud and put it there. But the platform will run into the Nimbus, OpenStack or any OpenStack environment. So it really is not meant to be a private cloud. It's to be public and private. So I'm building it to be fully enabled to run on the public cloud, but the first deployments that we have today is all private. that direction.
I just want to ask your opinion about the security aspect of the connected world tomorrow. So today people can hack into your email or maybe Facebook, but would that mean tomorrow people can hack into your maybe your cook or your freezers?
Yes. That has been done already, actually. The people hacked their refrigerators. It was a big problem with... the security is a huge problem. We have a whole organization handling that. And one of the problems is that it's very easy to cripple the technology and make it unusable because it has to be very secured. But you know, it's what was the one that, I think an example was one of the Japanese toilets that was hacked because it was a very simple thing that people wanted to just approach it and then pair their phone to it, and that's it. Well, anybody going by the house could do that, right? And so the question is you have to compromise between the user interface and the security. And I think today, I think that is one of the problems that the industry needs to solve, because there's no security at all, none whatsoever. My thermostat in my house, right, is set up on the internet inside my house, and if you gain access to that network, you can change the temperature. There's no even authentication, and the reason that is because people have a hard time, you know, doing the security. We solve to a certain extent the Wi-Fi security by having a push button when, you know, you just pair the device and push the button, and that's how you create the security. But we haven't done that at the Internet of Things level yet. So I don't really have a good answer. I know we have a lot of people working on this area, and I think the biggest problem there is the user interface. It's just how do you get the user to secure these things and not just say, the heck with it. Yeah.
I'm giving a talk on that tomorrow as well.
Ah, excellent.
Thanks, Luca. I had just a quick question. Would complex event processors then be a new technology to most mobile service providers? Is that something that would be part of the platform?
Yes, it is not. It's been used in the financial markets extensively in other places, but in the world of networking, they've never really exchanged messages. They always exchange packets, and when you start going up to the level when you start exchanging messages, that's where that technology comes in. They haven't really used this before, even though it's very useful to correlate events, you know, maybe network events, failure events, or load events, whatever it is. In our case, we're using it to manage the load and correlate load events, but that is a new technology. They haven't been using this before. Okay, I think we're out of time.